Hi everyone. Today I will address with you the second part of chemical equilibrium. In the previous video we addressed all the related parameters affecting the chemical equilibrium. And today in part 2 we will show how to solve chemical equilibrium problems without mistakes. So this is considered as exercise for chemical equilibrium. So listen carefully and prepare your pen and paper and write with me. And if you still have any concern, please drop your comment down or email it to me as per email mentioned here. Before starting, please, if you didn't register or subscribe, please subscribe and initiate the bell ring. And at the end, if you like this work, please press like. Let us go. Hi everyone, welcome back again to the equilibrium part 2 for problems and exercise. What about the definition of chemical equilibrium? Just for revision, what is the definition of chemical equilibrium? The chemical system is said to be at equilibrium when the rate of reactants is equal to the rate of products. I mentioned this very clear in my previous video that we have to consider what about the rate of reactants. The rate of reactants. It doesn't mean any concentration. If you remember this discussion which I had in my part 1, I told you don't confuse about rate of reactants as it is a function of concentration. This is not a concentration. Just only rate of reactants is equal to the rate of products. Here in this part 2, in this video, we will consider concentration. And so what is the reaction rate? It is the change of concentration by time. Change of concentration. So we will consider concentration either for reactants and concentrations of products by time. So the rate is the concentration of reactants or products minus concentration of reactants or products initially. So we have final stage and initial stage. Over time, time as well, final time minus initial time. My exam tips in this way, the first point, units of concentration should be in mole per liter. And if it is not so, please convert it to be mole per liter. If it is mole per 3 liters, you have to convert this to mole per liter, and so on. If it is less than liter, you have to convert it to liter. This is very, very, very essential and very important. And the examiner during the exam can put something like this and would like to test you whether you picked up this or not. So I am here, I told you, so no excuse. The second exam tips here, time in second. If you see something else, please convert it to second. Let us see example. A 2-liter flask contains 2 to the negative 3 mole per liter for hydrogen gas. The same for chlorine and the same for hydrogen chloride. At equilibrium as per equation, hydrogen plus chlorine produce hydrogen chloride, HCl. Calculate the equilibrium constant K for this reaction. Again, as I mentioned in the part 1 for equilibrium chemically, that you have to balance the equation. If you are given equation without balancing, you should balance it. So all this chapter, all this video based on 100% on the balanced chemical equation. If you didn't balance this from the beginning, you will lose its mark. You will take big 0. So here I would like to highlight this once again. If you are given any equation, first of all, have a look whether this equation is balanced or not. Quickly. Is it balanced equation or not? If it is not, you have to balance this before starting work. Otherwise, you will be mistaken. Again here, I stressed on this. Okay, remember me if you dropped in this mistake later on. Here is a concentration of hydrogen, like concentration of chlorine, like concentration of HCl. It is 2 to the power of -3. But we divide all of them over 2. Why over 2? Since it is mentioned that in 2-liter flask. This is very important. You have to read carefully the example or the question. You have to read carefully. You might be given this in the forefront of the question or at the end. At the end you will be in hurry. You understood everything you would like to say, start solving. And they didn't recognize that the tricky point here, it is in 2-liter flask, or 3-liter flask, or in quarter flask, or whatever. So the new concentration here, it is 0.001 for all of them. The second point, write the K equilibrium constant equation. As I mentioned before, the equation, it is concentration of products over concentration of reactants, and each products or reactants should be to the power of its coefficient. That's why I told you the balanced equation here, it is very important, since if you didn't balance the equation, so you will not know what about the coefficient. For example, here for HCl, to the power 2. Why 2? Since the equation is 2. The coefficient here is 2. That's why here HCl to the power 2. Okay, we agreed? You have to balance the equation first of all before starting your solving the equation. So hydrogen chloride HCl to the power 2 over concentration of hydrogen multiplied by concentration of chlorine. Here the coefficient of hydrogen and chlorine is 1. That's why we omit 1. But it is 1 and here 1. Okay? If you multiply this over that, you will find 0.001 squared. So concentration of products here, it is 0.001 squared over concentration of reactants 0.001 multiplied by 0.001. So the K, the coefficient of equilibrium here will be equals 1. Another example, calculating the molar concentration of a gas using K equilibrium. The question says, at equilibrium, the concentration of oxygen gas and nitrogen gas are 4.3 mole per liter. What is the concentration of nitrogen oxide gas? Here is the chemical equation. Oxygen plus nitrogen gives nitrogen oxide, and the K here is 6.2 by 10 to the -4. Again, here I would like to stress on something very important. As I mentioned in volume, in part 1 in equilibrium constant, that we have to look at this here. This is gases, or gas and liquid, or gas and water, or ecosystem, or what. You come back again to see when we can omit something and when we can consider something else. I discussed this in more details in part 1. So please, if you have any doubt about this point, please back again to the chemical equilibrium part 1. The solution. Molar concentration provided. Here, it is given. So K here, it is nitrogen oxide to the power of its coefficient, which is 2. Look, nitrogen oxide to the power of its coefficient, I mean to the power 2, over oxygen to the power 1, since the coefficient here is 1, and nitrogen here coefficient is 1. So substitute 6.2 by 10 to negative 4 equals nitrogen oxide squared over 4.3 by 4.3. So nitrogen oxide here by substitution will be 0.1071 mole per liter. Here we will address something more, which is equilibrium constant Kb. What is Kb? For gaseous homogeneous system, the measurement of relative quantities of reactants and products are partial pressure rather than concentrations. So the Kb here is instead of K equilibrium. The same situation, same equation, everything is the same, but the difference here, we will consider partial pressure instead of concentration. And here is an example: carbon monoxide gas plus hydrogen gas produce methane, CH4, and H2 water gas. Gas here means steam, so it is not liquid. Okay, so you have to consider this, very important. Here it is K for partial pressure of methane multiplied by partial pressure water over partial pressure of carbon monoxide multiplied by partial pressure of hydrogen to the power 3. Why to the power 3? Since the hydrogen here, balanced equation, hydrogen here coefficient is 3, so should be substituted by hydrogen concentration to the power 3. Equilibrium expressions and ice tables. What ice tables? We will see. When solving more complicated problems involving changes in concentrations or pressures, we set up tables. Tables list the initial concentration, the change in the concentration, and the equilibrium concentration. The abbreviation IC here coming from this. That's why it is ice tables. To solve these problems, you need to solve X. X, this is the quantity or partial pressure which reacts. It is given a symbol X. You might need in the complicated form to arrange your expressions in the form of quadratic formula to solve X. If you remember, the equation AX squared plus BX plus C equals 0, quadratic equation, and the X here give equals to minus B plus or minus the square root of B square minus 4AC over 2A. So here X represents the change, includes the coefficients that appear in the balanced chemical equation to show molar relationship of the components in the reaction. It is very important, again, the balanced equation. Don't forget this, the balanced equation, this is the key here to answer all of these equilibrium problems. Very important, very important. In solving the problems, you have to put negative sign to include that the change will decrease the initial concentration. So if the concentration will be decreased, so the X should be negative x. And say for example that the coefficient based on the balanced equation, it is 2, for example. So it will lose minus 2x. Why 2? Since the balanced equation coefficient mentioned it is 2. So it is very important. The same scenario for positive sign. Put positive sign to indicate a positive change to the initial concentration. So any reactants or products will gain something, you have to put plus x. On the other hand, if it lose any quantity or partial pressure, should take minus sign. Okay? Taking this example, given the initial partial pressure of BCl5 equals 0.05 atmosphere, and partial pressure of BCl3 equals 0.015 atmosphere, and the partial pressure of BCl2 is equals 0.25 atmosphere at 250 degrees Celsius. For the following reaction, which must each equilibrium partial pressure should be. Here the question is, what must each equilibrium partial pressure should be means you have to calculate all partial pressures to justify the equilibrium partial pressure. So you have to continue solving this problem to the end. So what about the equation? Equation here, as mentioned here, PCl5 gas produce PCl3 gas plus chlorine gas, and the coefficient here is 2.15. Here it is required to determine reaction quotient Q. If you are confused about this, I mentioned this clearly in part 1 equilibrium. You can back again to this video to see what about the reaction quotient, the action quotient Q. The reaction quotient Q equals, based on the equation, balance equation should be balanced. So what about the products? 0.15 multiplied by 0.25 over 0.05 equals 0.75. Shift to products. All chemical equations, reversible processes, we have mentioned all of this in part 1. To shift to the product, to shift to the reactants. If you would like to learn more about this, you come back again to our part 1 section. So make a chart describing relationships in change. This table is ICE, ice chart, ICE, ice chart. This is initial concentration, which is 0.05, and initial for BCl3 was 0.15, and finally initial for chlorine it is 0.25. Why it is not 0 like before? Since it is given clearly in this question. So this is a reversible process, and it is mentioned that at certain stage of the reaction you have concentration of products and concentration of reactants as well. So it is not in all cases that concentration of products will be 0. It depends on the question, first of all. Second one depends on the reaction. Does the reaction start yet or not yet? If the reaction doesn't start yet, so you will find products will be 0, 0, 0. But if the reaction started and you have reactants and products, so you'll find concentrations, initial concentrations of reactants and products as well. This is the first row, which is initial concentration. Second row is the change. What about the change in partial pressure? We say it is X. We consider it is just only give it abbreviation X. Okay. Why it is minus? Minus means it lose certain pressure. It lose. That's why it is minus. Here in products, it will gain. This is will lose and this is will gain by the same coefficient based on the chemical equation. If the chemical equation here, coefficient here, it is 1, so here it is just only x. If it is 2, should be plus 2x and so on. That's why this is the importance of the balanced chemical equation. You have to take this in consideration. Chlorine as well. This is the second product and it will increase its partial pressure by plus x. So at equilibrium, multiply this and that. Initial plus change. It is 0.05 minus x and this is 0.15 plus x. This is 0.25 plus x. So plug into equilibrium expressions and solve it for x. So 2.15 it is given. Okay? This is Kb. So products over reactants to the power of coefficient based on the balanced chemical equation. Okay. So 0.15 plus x multiplied by 0.25 plus x. All of them to the power 1, since the coefficient here is 1. All of them over 0.05 minus x. So x will be 0.0272. Okay, now determine concentration. .05 minus x, and here in products 0.15 plus x, and this is 0.25 plus x. Substitute x here by 0.027, so it will give you 0.0228, and this is 0.177, and this is 0.277. Finally, confirm value of K with these values to check your answer. If you remember, 2.15 is given. If you multiply but all these values which you are just now getting right now, these recent values here at equilibrium, if you multiply products over reactants, we will find this Kb the same. Another example. If the equilibrium constant for the following reaction is 0.1, determine the final concentration of iodine chloride if 4 moles of iodine and chlorine were entered. Yes, it is mentioned here that it is empty 1 liter flask, initially into 1 liter flask. So this mole concentration, it is per liter. So what about the balanced chemical equation? Iodine plus chlorine equals ICl. Should be balanced equation. Balance means here you have to put here 2. Should be balanced equation, okay? Initially 4 moles and 0 moles. Why 0 moles? Since initially there is no products. There is no iodine chloride. That's why 0 initial concentration here. Okay, what about the change? The change is x and the iodine will lose something. So it is negative x. And chlorine the same. Will lose x. So minus x. And what about the product? Will gain. So plus. Plus what? Plus 2x. Why 2? The coefficient based on the balanced chemical equation is 2. So it will increase by its coefficient. So it is plus 2x. At equilibrium, add this plus that. Initial plus change. So 4 minus x and 4 minus x will give 2x. Plug into the equilibrium expression and solve it for x. So 0.1 equals 2x to the power 2 squared over 4 minus x squared. So x equals 0.546. Now determine concentrations. At equilibrium, 4 minus x. X it is 0.546. So 4 minus 0.546. 3.5. And this is the same, 3.5. And this is 1.1. Here it is required to know this. It is 1.1. 1.1. Okay. Another question here. The following reaction has an equilibrium constant of 620 at a certain temperature. Calculate the equilibrium concentrations of all species if 4.5 mole of each component were added to 3 liter flask. Take care. 3 liter flask. Here it is mentioned 3 liter flask at the end. So if you read the sentence very quickly and you didn't recognize 3 liter flask, you will not solve the equation properly. So hydrogen plus fluorine gives hydrogen fluoride. Here this is for balanced equation. The equation should be balanced. So determine the molarity of solutions 4.5 over 3. Why over 3? Since it is 3 liter flask, all of this quantity in triple volume, but we need just only 1 liter. 1 liter. That's why you have to divide this mole by 3. So it is 1.5 of all solutions. That's why here it is 1.5 mole and fluorine 1.5 mole, and here it is 1.5 mole. Why it is not 0 here, my friend? It is given like that. On the other hand, it is not initially, it is during the reaction. During the reaction it is reverse process, which means you have reactants and products. So what about the initial reactants at that time? It was 1.5 for reactants and 1.5 for products. So the change here it is x. So hydrogen will lose x, so it is minus x. The same, fluorine will lose x, it is minus x. But hydrogen fluoride will gain x. How many x should be gained? Plus 2x. Why 2? Since the coefficient here of the balanced equation mentions that the coefficient is 2. Okay, at equilibrium, add this or that. This with that. So 1.5 minus x, 1.5 minus x, and this is 1.5 plus 2x. Plug into the equilibrium expression and solve for x. So 620 it is given, 620, this is k, equals 1.5 plus 2x squared over 1.5 minus x squared. So x here will be equals 1.3. So finally determine concentrations. After will be 1.5 minus x. So it is 1.5 minus 1.3. It is 0.2 mole. Same for fluorine, 0.2 mole. And here it is 1.5 plus 2x. And 2x here 2.6. So this plus that, it will 4.1 mole. 4.1 mole. Please, if you are talking about concentration, don't forget to mention its unit. Its unit here, mole per liter, mole per liter. Don't say 4.1 and that's it. No. Here concentrations should be attached with its unit, Don't forget. In this example, ammonia undergoes hydrolysis according to the following reaction. Ammonia aqueous system plus hydrogen liquid gives ammonium chloride, ammonium plus ammonium cation plus hydroxyl anion. This hydrolysis in presence of water. Okay? What about the difference between liquid here and aqueous? No, the liquid here will not be considered. If you are doubt about this point, you come back again to our part 1 for chemical equilibrium. We have mentioned this in more details. So here calculate NH3, NH4 plus hydrogen plus hydroxyl anion in a solution originally 0.2 mole NH3. So it is given here only the reactants, it is 0.2 mole NH3, and hydrogen in water here it is 0. Not considered, huh? Not considered. Why not considered? I told you to back again to the part 1. Here it is ammonium cation 0 and hydroxyl anion 0. Aqueous. You will consider aqueous solution. What about the change here? NH3 will lose something, so we'll lose minus X. And all of the products will gain something, the same. Plus X. Why plus X? Here is a coefficient here. As per balanced equation, it is 1. Here 1 and here 1. So it is the same change, plus X. At equilibrium, add this row plus this row. So 0.2 minus X, and this will be X, and the product here it is X. So plug into the equilibrium expression and solve it for X. So 1.8 by 10 to the negative 5 equals X squared over 0.2 minus X. Why X squared? This is X multiplied by X, so it is X squared. And why it is 0.2 minus X? This is the reactants. So products over reactants. So X here it is 0.0018. 0.0018. So finally determine concentrations at equilibrium. 0.2 minus X. Here 0.2 minus X for NH3. So it will be 0.198 mole. While each products here it is X, it is 0.002, and this is 0.002. Let us take another example. The equilibrium constant for the following reaction at 600 degrees Celsius is 4. Initially, 2 moles of carbon monoxide and 1 mole of hydrogen oxide, which is water, were mixed in 1 liter container. Determine the concentration of all species at equilibrium. Carbon monoxide 2 moles and water gas 1 mole. Why you consider this concentration of water? In the previous example we have mentioned that water will be omitted. We will not consider water in liquid as a liquid, but here water in gaseous form. That's why it should be considered. To produce carbon dioxide gas plus hydrogen gas. So 2 moles of carbon monoxide plus 1 mole of water gas initially. And at the beginning there is no carbon dioxide nor hydrogen. So change here will be minus X plus X plus X. Why minus X here? Since carbon monoxide will lose some concentration. And why just only 1X? Since the coefficient here is only 1. Same for water in gaseous state. To produce carbon dioxide, which is plus X, it will gain something. It will gain. That's why it is positive. And hydrogen, it will gain X as well. At equilibrium, you can add this row with that row. So 2 minus X, and here 1 minus X, here X and X. So plug into equilibrium expression and solve it for X. So 4 it is given. Equals X squared over 1 minus X multiplied by 2 minus X. So X will be equals 0.85. So the last stage, it is determine concentrations at equilibrium. 2 minus 0.85, which is 1.15 for carbon monoxide, and for H2O gas 1.0 minus 0.85, which is 0.15, and finally for carbon dioxide it's 0.85 and hydrogen gas 0.85. At the end of this part, now you are fully aware and can solve any chemical equilibrium without any mistake. So put in your consideration all tips, all recommendations, all my advice while illustrating all of this example with you. And if you're still doubting from anything, please drop your comment down, or you can email it to me. If you didn't subscribe in this channel, this is your channel, Exam Tips. If you didn't subscribe, please subscribe and highlight the ring bell. If you like this work, please press like, and see you for the next video. Bye.